hope you're already familiar with the basic trigonometric ratios. We have, first of all, the sine of theta. Now remember that theta always represents our angle measure. So anything written beside sine, cosine, or tangent is our angle, either in degrees or radians. If you look on a calculator, you're going to see sine abbreviated SIN. So let's call this angle here theta. It's going to be the angle between our initial side and our terminal side. We can label the sides of this triangle according to theta. So this side here is opposite our angle. Now I have two sides. They're each touching our angle. They're each adjacent to our angle. However, we know that the longest side is always called the hypotenuse. And that means that here we have the adjacent side. Each of these ratios just describes a relationship of the sides depending on the name. So the sine ratio is the relationship of the opposite side over the hypotenuse. The cosine ratio, the cosine of theta, abbreviated COS, is always comparing the adjacent side to the hypotenuse. And the tangent ratio, abbreviated TAN, is always comparing the opposite side to the adjacent side. Some of you might have learned this handy abbreviation known as SOHCAHTOA. Where we say that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is the opposite over adjacent. As you move further along in mathematics, we move away from using opposite, adjacent, and hypotenuse, because we want to take our triangle now and draw it inside the coordinate plane. So you can see that I've drawn a triangle in quadrant 1. We have our y-axis and we have our x-axis. And remember that we always start measuring our angle on the terminal side. And so we have our angle theta here inside our triangle. It looks quite similar to the triangle we've drawn here. Theta is in the same place, our right angle's in the same place. But what we're going to do now is we're going to say that this side here along the x-axis is going to be called x, because its dimension, its length, is however far it reaches on the x-axis. We're going to look at the vertical side and see that it corresponds to some length y. What about the hypotenuse? Well, if you imagine that this terminal side keeps going around in a circle, then that hypotenuse has become the radius. And we're going to call this side R. Notice, because we're drawing our triangle on the XY axis, it will be possible for X and Y to be negative. If we had a real triangle, we could never have a negative side length. But because we're using the coordinate plane, it is possible. We will note, however, that R, the radius, is always positive. It will never be equal to 0. It will never be less than 0. But this allows me to rename the ratios a little bit. Now for sine, the opposite side has become y, and the hypotenuse is r. For cosine, the adjacent side is x, and the hypotenuse is r. For tangent, we have the opposite y over the adjacent x. Notice what we've also said here, that r will never equal 0. And it's important to note for tangent that x can't be 0, because if x is 0, our ratio would be undefined. Make sure you memorize these. I don't care, put them on your fridge, on your phone, by your bed. I'm going to ask you to be writing these down over and over and over again so that you have them memorized.